Hello students. In the last video we have discussed about normal forms for context-free grammars and especially Chomsky normal form. So in this video we'll discuss about Greiback normal form. So first of all, what we are having two types of normal forms, Chomsky normal form and Greiback normal form. Right? We have discussed what exactly all these things in the last, but why we have to use, right? So if you want to convert CFG to PDA, first convert the grammar. Directly we can do it, but it is complicated thing, right? And we don't have any particular algorithm to do that. So manually you have to do it. Then if you convert the context-free grammar to GNF, then if you run the algorithm directly we can convert into the PDA, and the PDA can be either DPD or NPDA, depends on the particular language. So the class of languages which are accepted by the DPDA and NPDA, which are accepted, which are not accepted, we have discussed about the types differences in the last unit. In this unit, maybe in the next video or after that, we'll discuss what are exactly the languages accepted by the DPD and NPD. Okay, we'll come to that, come back to this. So if you want to convert into the PDA, then again you can represent the CFG in a CNF. Then again you can run the algorithm that can be even converted into the PDA. So conversion of directly is also possible, but it is somewhat complicated, right? And manual thing. And if you represent in the normal forms, by running some algorithm, we can do that. Okay. So what is CNF and what is GNF? Let me write quickly. So CNF means left hand side only one non-terminal, right hand side either two non-terminals or a single terminal is allowed. In Greiback normal form, we have already discussed right hand side. A terminal is followed by any number of non-terminals. Means no non-terminal is allowed. That is, A tends to a single terminal is allowed. A tends to a terminal followed by a non-terminal is allowed. A tends to terminal followed by any number of non-terminals also allowed. So terminal must be occurred as a first symbol. Non-terminal must be occurred as second, third, and fourth one. But non-terminal must not be as a first symbol. Right? Then how can we do this? So the definition here you can take it A tends to A alpha, where the alpha must be only variables. Variables means non-terminals. So if you are given a grammar and you are asked to convert into the GNF, make sure that the grammar does not have epsilon productions. Why? Because we don't support that, right? Null productions, terminal followed by any number of non-terminals. No unit productions, because right hand side single non-terminal is not allowed in both the grammars. No useless, this won't affect on your grammar, but it will affect on your conversion algorithm. So taking extra productions and repeated things, and of course, which is these three are even common to CNF, but the only specific to the GNF is make sure that that must be free from left recursion. Otherwise, it will enter into the infinite looping. Of course, here also we have a two steps. Let me write it again. The step one, right? Same, whatever we have taken for the CNF, same step you have to do. So first, identify the terminals which are in wrong place. Identify terminals which are in wrong place. Wrong place. Then introduce new non-terminal for them. Then replace with a new non-terminal. Replace with new non-terminal. Don't use the existing, right? Sometimes we can, but don't prefer it. Second one, identify, or if a non-terminal is in wrong place, right? If a non-terminal in wrong place, then replace the non-terminal, right, with all of its productions, all of that non-terminal productions. That's it. Two simple rules to convert into the Greiback normal form. So I would have written this before, right, while preparing, but see, you'll get some impact while giving the means while writing. There's a reason I didn't write these two statements for even CNF and GNF also. Okay, let me go with this. The first step here, what we are doing simply in the first step, right? First, identify the terminals which are in wrong place. See, this is not in wrong place because the production must start with the terminal, but this is in wrong place, B. So replace it with a Y. And see, no problem with this, but this must not be as a second symbol. Replace it with the X, right? So non-terminal must not be occurred. I'll go with the first one, terminals only. So the terminal must not be occurred as a other positions except the starting. So second symbol not allowed. No problem here, but here the problem. And no problem here, right? And here the problem. And no problem here. Then what we can write after the first step? So simply you can write in this way. S tends to AAYA, right? Let me write individually. S tends to AXB and S tends to AX, right? Then A tends to BB, no problem with that, and A tends to BY and A tends to A. Then B tends to AXB, then B tends to B. So what is X here? A. What is Y here? B. Actually you have to write support this at any place, no problem, but better to write after that, as I don't have the space, that's why I wrote here. Now see how many productions are already in GNF which are violating that, which are not violating. Of course, no problem with this. See, no problem with this. Terminal followed by any number of terminals. Terminal followed by any number, no problem with this. So this is already in the GNF. And but see, this is not in GNF because the first symbol must not be occurred as a non-terminal. Non-terminal is violating the rule. No problem with this. And see here, the non-terminal is violating the rule. Right? These two are not in GNF. No problem with this, no problem with this, no problem. So what you are supposed to do, guys, if a non-terminal is in wrong place, simply replace that non-terminal with all of its production. First I'll go from down. So here B should not be occurred here. Then replace this B with all of its productions. Okay. Then what will be happened here? It's very simple, guys. You can take it same way. So S tends to AAYA or AXB. Let me write in that way only. Or AX. Space is not sufficient. Then you can write A tends to BB. Right here you can take it. A tends to, in place of this B, substitute all of its production. 2, right? First substitute AXB. You'll get AXBY. In the next step you substitute B. So you'll get BY. Then what are the other A productions? A tends to A. Then, okay, so B tends to AXB. Then B tends to B. Right. So I've just eliminated the non-terminal from here. Then what we can do here, then you can go with this. So all are in GNF here, no problem with this. But except what? This AX. Now you substitute this A with all of its A productions. Now we are having 3. Then what will be happen here in the next space? Okay, you can write in this way. So you can write S tends to AAYA or AXB. In place of A, substitute all of its productions. Then you can write this separately. S tends to A. A means BB substitute. You'll get BBX, or you substitute AXBY here. Then you'll get AXBYX. Then you substitute BY. You'll get BYX. Then you substitute A. Then you'll get AX. These are the S productions. Then write down remaining all the A productions as it is. A tends to BB. A tends to AXBY or BY. And A tends to A. B tends to AXB. And B tends to B. That's it. See? Now all are in GNF. Right, but you have to do it one by one. Don't replace A with A and B at a time with all of its productions. If you are having such 3 or 4 non-terminals, do it one by one, no problem. You do it one by one, definitely you'll get the answer. But don't do all at a time. Okay. So let me go with one more example which is given here. Right. See, you can take this as X, but Y, then X, then sorry, you can take this B as Y. No problem with this, right? Sorry. No problem with this. Let me just go with this. So no problem with this, but here you replace with the y, and here you can do with the x, and here you can do with the x, y, and x. No problem with this. You can write like this: s tends to sxs sy, right? bax. Then a tends to bxb bar by. Then b tends to brd, and x tends to a, y tends to b. Guys, you can use whatever the symbol you want. There is no restriction at all. Right, let me go with this again with the production here. So here we are having GNF, 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 but this is one. So substitute this B with all of its productions. Then you can take S tends to SXS, SY, BAX. Then A tends to, in place of B, substitute once B, once D. Then BXB, DXB, and write down the remaining all the productions as it is: BA, BY. Then B tends to B or D, X tends to A, Y tends to B. Right, then what we can do in the next case, right? See, we are having here yes, and the first symbol yes, first symbol s. So first you'll go with this, replace this s with all of its productions. So what will be happened here? So s tends to sxs, in place of s substitute all the three productions. Then what will be happen? sxsy, syy, and again you substitute baxy, and already we are having BAX earlier. See, in place of this, already we are having two productions, SXX, BAX. In place of this, yes, again you substitute all the S productions. See, the number of violations have been increased. Earlier we are having only one violation, sorry, two violations. Now after substituting, we have how many? Three violations. Now, in place of this, yes, you substitute all the five production, you will get 9. The number of productions are going to be increased and iteratively will infinite. That's a problem I told you. Because why can't I substitute this? Because the grammar is left recursive grammar. There's a reason we cannot convert it. Got my point? That's why I told you. See, again, if you are having a violation here, then substitute this S with all of 5 productions. Already we have 4, then you'll get 5 more, 9. Still you are going to have the left violations. So that's the reason. First, if you are given a grammar, make sure that no epsilon productions, no unit productions, no useless symbols, and for GNF you have to ensure that there is no left recursion also, right? So to do that left recursion elimination, and you can convert it, you'll get that. So then what are the observations of it? Greiback normal forms are very good for parsing compared to CNF. But the thing is, it is very hard to find the Greiback normal form compared to finding the CNF, right? So in the next video, we'll discuss about pumping lemma for contextual languages. Same pumping lemma we have used even for the regular languages. So now how we'll use this pumping lemma for CFL? Same. The pumping lemma is used to check whether the language is not CFL, not whether, to prove that the language is not context free languages. So that we'll discuss in the next video.